Good afternoon and welcome to the session number 23 from the chapter of Heat and Thermodynamics. The topic is the calculation of work done and the change in the internal energy of a substance upon heating. So based on this topic, I have one question for this session which is written here on this board. So the question here is 1 gram of water at 373 Kelvin is converted into steam at the same temperature. The volume of the water becomes 1671 cubic centimeter upon boiling. So we have to calculate the work done and the change in the internal energy of the system if the heat of vaporization is 540 calories per gram and the standard atmospheric pressure is equal to 1.013 into 10 to the power 5 Newton per meter square. So again in this question we will be using the first law of thermodynamics, that is delta Q is equal to delta U plus delta W. Here delta Q is the amount of heat supplied, delta Q is the change in the internal energy of a substance, and delta W is the work done. So here work done will be equal to P delta V. Now here the standard atmospheric pressure is equal to 1.013 into 10 to the power 5 Newton per meter square. So this will be equal to 1.013 into 10 to the power 5 Newton per meter square multiplied by the change in the volume. Now here the volume, this is 1 gram of water which is getting converted into steam at 373 Kelvin. This is equal to 100 degrees centigrade. So here the volume, so 1 gram of water is equivalent to 1 cubic centimeter. So the change in the volume will be equal to 1671 minus 1, which is equal to 1670 cubic centimeter. But we have to convert it into cubic meter. So in cubic meter, this will be equal to this will be equal to 10 to the power minus 6. So this is the change in the volume in cubic meter. So the work done, this will be equal to 1.013 into 1670. This is equal to 1691.7. 1691.7 into 10 to the power minus 1, or this is equal to 169.17 joule. So the work done in converting this water into steam at 100 degrees centigrade or 370 Kelvin is equal to 169.17 joules. So I will be writing here work done is equal to 169.17 joule. Now the second part of this question is the calculation of the change in the internal energy of this system, and so delta U, which is the change in the internal energy of this system, this is equal to delta Q minus delta W. So delta W has been calculated. Now we have to find the value of delta Q. Delta Q is the amount of heat supplied. Now here the water is getting converted into steam at the same temperature. So here the water will be absorbing the latent heat of vaporization. So here the heat of vaporization is given to us as 540 calories per gram. So delta Q, it will be equal to how much? This will be equal to 540 calories. Now in order to convert this into joule, I will be multiplying it by 4.18. So this is in joules. This is equal to 4.18 multiplied by 540. This is equal to 2257.2. 2257.2 joules. So the change in the internal energy, that is delta U, this will be equal to delta Q, that is equal to 2257.2 joules, minus the work done, which is equal to 169.17, 169.17 joule. So this will be equal to 2257.2 minus 169.17. So this is approximately equal to 2088. 2088.03 joules. So the change in the internal energy is equal to 2088.03 joules, and the work done is equal to 169.17 joules. So thank you very much for joining this session. Now in the next session again, I will be coming up with a different type of a question from the same topic of First Law of Thermodynamics. So till then, have a nice day. Bye.